Hello, my geometry friends. I am Mr. Butterworth.
I'm Mr. Carlson.
We're going to talk about points, lines, and planes. There's a lot of vocabulary we need in geometry in order to sound somewhat smart. I don't know, somewhat knowledgeable about
Uh,
geometry. And that's what we're going to get into here.
and really to be able to communicate clearly with each other using language that we can all understand.
That's probably a smarter way of putting that.
One of the weird things in geometry is we start off our learning with three terms that we call undefined because we can't have really a mathematical definition for what these things are. In all of these cases, we're able to pretty clearly understand what we're talking about when we say a single point or a line or a plane, but writing down words to create some kind of mathematical definition doesn't really work so well. One of the ways that I often think about a point is that a point is something that identifies a location in space. Is that a pretty fair definition, Mr. Butterworth?
Yeah, I would do that. It's just some sort of location somewhere in space. We don't know where it is, but that's how I would define it.
And
I drew both a point and a line because I figured that we all would kind of have an idea of what those look like. I didn't draw a
yeah,
plane yet.
and dealing with a point, if this were, I don't know, let's call this point A. We could name this with words as point A, or if we just describe A on its own, we're talking about a single point. One of the reasons that makes these things hard to define is because we're dealing with something that's we say is infinitely small or it's infinitesimal. Those are words that mean that this point doesn't have a length or a width or a height. It's just there. It's just information. And that's why these things are really hard to get our brains around. All right, so how about a line? We've been using lines all the way through middle school. And here we've identified a line that has 2 points identified on that line.
Now, it's important to note the points there. I just drew two of them. So there's points everywhere.
Mm,
But I just picked the letters M and Q because I didn't want to be boring and pick the first letter of the alphabet.
yeah, so you're saying that there's like a point here and here and here and here and here and here, and all the points between those places as well. The other characteristics of a line are really confusing because we have two different types of infinity going on. The first is that this thing is infinitely long. It's going to keep going in the same direction forever in both directions that it goes. And the
That's
same,
the arrows on the ends of that.
yeah. And at the same time, it's infinitely thin. So this is something that we have a clearly, it's an infinite length, but it doesn't have a width or a height. And we have one dimension that we can measure this in. What do we think are some good words to describe that, Mr. Butterworth?
Not having a width?
Just a line in general, because we kind of rambled a lot there.
Oh, maybe we can say, I'm thinking a collection of points, but that doesn't seem specific enough.
Maybe he's talking about, I mean, and literally this is why these things are undefined. So we're doing a nice job of stumbling through clear language to say this, but this is why we define these things as undefined terms.
So maybe a collection of points continuing infinitely in two directions?
I'm going to say a collection of all points. I was going to say on a line, but that's not helpful. Continuing infinitely in both directions.
Or in two directions?
Yeah. And we're going to have a word that we can use to talk about these points on the next page, I think.
Yeah, I'm thinking maybe we need to put the word opposite right here. Opposite directions.
Yeah, that makes sense.
But again, I'm not
Um,
going to really ask you specifically to define what that is because you can't really do it, as you've noticed from the fact that we've been rambling for over a minute now about it.
right. So getting an understanding of what it is, but not being able to explain it, that's okay for this thing. All right. And then we have our new thing, or at least maybe new thing, which is talking about a plane.
Before we jump to that, I did write
Oh,
MQ with a line above it, and that is how we will be defining or naming that thing. If we're talking about line MQ, you write down MQ, and then, but don't forget the line above it.
so the line above it with the arrows that's what tells us that this is a line MQ instead of some other type of geometrical figure.
Yes.
Would it also be okay to read this backwards and call this line QM?
Ooh, well, lines go on forever, so yeah, that'd be fine.
Okay, so for lines, we can switch the order around. What if I just wanted to call this line M? Is that okay?
Not the way we've defined what M is. In some places, they will define a line as a letter. They often use a cursive letter. Like they might at some point put like an L. Oops, that's an eraser. Put like an L over here. And then they'll talk about that as line L.
Cool. I like that. But because M is just a single point, we can't use that as the name of the line.
Correct.
Cool. All right, so now we're ready to jump to planes. Not jump
Yes,
from planes where you need a parachute, but jump to planes.
that's a math teacher requirement that you have to make a joke about a plane when you're
That's
talking
true.
about planes.
Um, and then we can use, I think, what we've talked about as far as like a point having no dimensionality to it, so we can't measure it in any direction. A line, we can measure it in this one direction going out both sides infinitely. And a plane, which we often visualize as kind of like a sheet of paper, but going on forever, we can measure in two different directions. That's why we include the word opposite there. So we can talk about both the length and the width of a plane in terms of that. And again, these are going to go on forever in all directions. So would we maybe classify this the same thing, where we have a collection of points?
Well, it's going to be in the way. I'm going to erase it.
No, you're good. But you're going to erase it anyway? I like it. So we've got a collection of all points continuing infinitely. And how do we want to say this? Because we said the other one in two opposite directions. Could we say in two dimensions instead? Is that too
You
like
could
heavy
say
a math word?
you can also, I mean, another way that I've defined plane would be a flat surface that has no thickness,
I like that.
which is not as mathematical, but maybe makes a little bit of sense. You can think of it as a piece of paper, like you can have the plane of the piece of paper or the plane of what we're writing on right now or something like that. But technically speaking, geometrically speaking, it does continue kind of infinitely in the directions of the paper.
Yeah, I think that those two things combined makes a pretty good understanding for this.
And I'll
All
draw
right.
my plane back in. So I put 3 points on that plane because usually we're going to talk about it in terms of 3 points. We'll talk a little bit about why at some point, but I made it jam because we're currently writing in a Jamboard.
I like it. And could I just write the letters jam, or do I need some kind of symbol to show that that's a plane?
You can just write the letters jam. And again, sometimes people define the plane in terms of a letter, but that's not a point within the plane.
And I'm going to ask the same question I asked before. Would it be okay to call, instead of this plane jam, plane AMJ? Does the order of the letters matter for a plane?
Does not matter.
Okay, so
In
we can
fact,
switch.
if you had another point, maybe an S for jams, you would only need to choose any three of those letters.
Could you choose all four?
It's not conventionally done.
Okay, but we might see it sometimes depending on who the author for stuff is.
Correct. But the typical convention is to use the three.
Cool. So we have now three undefined things that hopefully we have at least some way to think about and some way to write. And I think I'm pretty comfortable moving on to talk about some things that are actually defined.
Totally ready.
All
And these are
right.
two words that kids often struggle saying, which really amuses me. So right now, if you want to, you pause your video and try to say those words out loud, preferably recording yourself and then like submitting it in your next journal simply so that we can hear you attempt to say these words. That would be fun. Because I've heard all sorts of pronunciations, and maybe Mr. Carlson says it differently than I. We'll see. I say these words as collinear and coplanar.
I also say them as collinear and coplanar. And hopefully we know the word or the beginning part of a word co means together. Like we are co-workers because we work together, or cooperate to operate together. And I think that makes these a little bit easier to understand. So collinear, linear together? What would that look like if things are collinear?
I think they would be cooperating on a line. So
All
you'd
right,
have
so,
a line. Oh,
yeah,
let me try. There we go. A line. And
cool.
then you'd have some points along that line. So those points are collinear.
What if I had a fourth point up here? So I don't know, let's say that we had these 3 points that are collinear in this fourth point. Could we say that all four are collinear because they're near the same line?
No, silly. They have to be on the same line.
All right, so would it be fair to say that collinear are points that we can draw a single line through?
Yeah, or points on the same line. Get rid of your point. Ooh, that was fun. I'm gonna set up the next picture while you're writing that.
Well, it's all done.
Beautiful.
So then coplanar, now that we know what collinear means, together planar, so together on the same plane. Any points that can be put onto the same plane we call coplanar. That was a fun one.
I was trying to highlight it, but then it was covered enough.
Yeah, it doesn't, highlighting doesn't seem to work so well, which is interesting. So if I had some points on this plane, these 3 points would be coplanar. And usually to show that something is not on the same plane, we draw like a point and then we'll draw like a dashed line saying that this is above it or below it.
Yeah, see, the struggle of this is in a classroom, actually, if they look at my picture right now, if you use think of my iPad, which I have to unplug, as their plane, coplanar would be like a point up here, not in my iPad. But since we're writing on a plane,
You mean not coplanar would be a point up there?
sorry, yes, not coplanar.
Yeah.
But since we're writing on a plane, it's harder to picture what that is. But if you think of the paper you might be writing on versus the tip of your pencil that you can hold in the air, the tip of the pencil is not in the same plane as the plane of the paper until you attach the tip of the pencil to your plane.
So would it make sense that we use the same type of wording there? Points that can be drawn all in the same plane, or you can draw a single plane through?
Yes. Or you can visualize a single plane through if you're not an adept artist.
Yeah, planes are tough. Anything that you get into 3D world makes things a little bit tough to draw. As you can see with my expert dash line three-dimensional drawing on the Jamboard.
All right, now don't freak out, guys. There's a few more words that we need to talk about. They're coming up, but then we'll actually get into some stuff that we can actually like maybe write some other stuff down.
All right. I've talked for a bit, so I'm going to let you talk about the what
Oh,
these things are.
okay. So we gave you these definitions because we kind of have to provide them to you. We could talk through them, but since this is a video, that's a little bit different. So a segment, part of a line consisting of two endpoints and the points in between them. So a segment is simply something like this, where I can pick PQ. In naming, like with a line, we write PQ, but then you put a segment above it. Don't put a line above it. You put a segment above it. You don't need to put little dots on the end of that segment above the PQ. Some of my students like to do that. You don't need to. You can just put the segment, and that's saying segment PQ. So when you read this part that says naming out loud that I circled, and it's going to show up there, you just say segment PQ when you read that. Similarly, a ray.
Before we talk about rays, would this also be one that it's okay to switch the order and write QP?
Oh yeah, that's a good call, Mr. Carlson. That would be great.
Because we're still talking about the same thing no matter which way we order that.
Yes.
Cool.
But if we talk about a ray, think of a ray of sunshine. That's what Mr. Carlson is in my life.
Aww.
And if you put C and then, I don't know, L, that is a ray, and you'd have to name it in one specific way. And now see how Mr. Carlson's putting the arrow above that? Because our society is dominated by right-handed people, we draw the ray to the right like that. That's the one area in my life that I am oppressed. You cannot. What are you going to do?
So is this okay for this one?
No, Mr. Carlson. If we wrote that, that would start at L. So I'm going to be a little bouncing point here. And then it would go away from L through C. And that would be wrong.
What about this?
Technically speaking, that would be acceptable. But again, since we live in a society where right-handed people dominate, we don't do that. So conventionally, we do not do that.
I wonder if in languages that aren't written from left to right, if that's a little bit more common to use the notation on the right.
That could be interesting, but I'm going to destroy it so that kids don't do it.
That's totally fine.
And because it's satisfying to see all those pieces destroyed.
That's true.
Now, the last part is an opposite ray, two rays that share the same endpoint and form a line. So if I take a ray, I'm going to draw it down the bottom because I want more space. I'm going to take a ray and I'm going to draw it to the left because I've been complaining that.
To the left.
Right. And I'm going to name it EI because I'm thinking of Old MacDonald. So that's a ray. Mr. Carlson's going to write that down as ray EI. And then I need another ray that shares that endpoint. So I need to go, but forms a line. So I need to go this away. And I'm going to put an O again because I'm still thinking of Old MacDonald. So EI and EO are opposite rays. You might note, this is important. They do, in fact, form a line.
So if I were to describe this as, in terms of line notation, IO, that would be okay?
That is line IO. You could name it line IO, IE, EO, OE. I'm not going to keep going, don't worry.
So for lines, as long as we choose 2 points that are on that line, we can choose any 2 points.
Yeah, boy.
But for rays, we have to include the endpoint with that.
And same with segments. We
Cool.
have to include those 2 endpoints. And I think that they can do this one. We'll put down the answers, but you should pause the video and you should write down all the segments you can. Did you pause it? Because you're supposed to have paused it. If you didn't,
I have not paused it.
Not you. The students.
Oh, the students. Okay.
Pause it. We're just going to keep rolling. We're good. So now we're going to write down all the answers. If you haven't paused it, now's your last chance because we're about to write down all the names of the segments in the picture. Okay, we're going to go. We have segment DE, segment EF, segment DF. That's it, right, Mr. Carlson?
That's it. The only other thing we could do is if we flip the order of those around, those would all still be okay.
That is
So we could
perfect.
have FD, FE, or ED, and all of those would be fine as far as names for segments.
Beautiful. Now in that picture, there's also a bunch of rays and a bunch of, it's fine if it's fine. Oh, we're going to go to the same picture. Look at that. There's a bunch of rays.
Oh, I was like, why did the things just, it's a different page. Whew.
So again, you should pause and you should write down as many rays as you can. Try to write it with proper notation. Think they paused by now?
Probably.
Okay, good. So now we're going to go through and do it. Mr. Carlson's going to write them down this time.
All right, I'm going to start from D as my first endpoint, and we've got DE. And then I'm kind of confused, because what about DF? Because those both start from the same endpoint and both go this way. Are those different or are those the same ray?
Those are the same ray, but different names.
Yeah, so that's kind of weird.
This question doesn't say distinct rays, which would be different
Yeah.
rays. That is acceptable.
So then I don't see any other ones I can start from D. So maybe I'll start from E next. I can go from E to F, and I can go backwards from E and go to D when I go from right to left. And then finally, I'm going to start from F, and I can go from F to E, and I can go from F to D. And I like what Mr. Butterworth is writing there. Those are opposite rags. Oh, rays. Because those are indeed two rays that have the same endpoint and together form a line.
Just the middle pair. Just the middle pair. I stopped paying attention, but I like what you did. It's beautiful, Mr. Carlson.
Yeah, and for something like this, I really tried to go letter by letter, and instead of just kind of randomly writing them down, just so I have some kind of order and can make sure I don't miss any.
We already did this one.
We already did this one.
So they should know how to do it. So we can just keep going.
I like it. All right, so here's another heavy vocab-y thing. In this class, we're going to talk a lot about why things are true. Why are you crossing out the word this?
I was trying to move it, and then I forgot what tool I was on. Sorry.
So in terms of the stuff that we're showing why things are true, some of the reasons we use are things that we call postulates or axioms. Sometimes we also call these properties. These are things that we can understand are true, but we don't have a mathematically accurate way to prove that they have to be true. We're going to see a couple examples of that in the next page.
Yes, they're basically things that we have to accept as fact and accept as true in order for everything to work. And that's all there is on that page. Ooh, how many unique lines can you draw through one point? All right, I'm going to draw one. I bet you can't draw another one. Ooh, I didn't draw the arrows. That's a close one.
I'm going to draw a different one in blue.
Ooh, I think I can draw another one.
I think I can draw another one too.
Should we draw as many as we? No, I'm just kidding. We can't. There are like a lot of them. We call that there are infinitely many unique lines.
Yeah, and so this is because, like, even if we could zoom in and really be able to draw between the spaces, hopefully we can see that there's not really ever going to be a way to stop drawing lines. You can just keep going. But what if we then have to connect 2 points instead of just one?
Hold on, I can do it. Whoop, I did it.
All right, I'm going to draw a different one. Did I do it?
I mean, it had a little wiggle at the beginning, but
Hey.
I get it. So you're saying it's the same thing?
Oh. So if up top we had an infinite number, then in the middle, it looks like, because those two lines are not unique lines, those are not different. So is it fair to say that there's only one can be drawn through 2 points, or seems to be the case?
Yes.
Okay.
Now the next one, I got it. Don't worry. I'm going to do this. Right. I did it.
Dude, that's not a line.
That's why I had it erase itself automatically.
A line looks like this.
Oh,
Uh,
but that doesn't hit any of the points.
no, I'm trying to think of a way to spin that and hit these. I don't think I can.
Oh, so does that mean the answer is 0?
I'm going to have to put a qualifier in here because if these 3 points were instead like this,
Oh. So
uh,
we should put 3, wait, we know this fancy word. 3
together line.
linear, but we don't want them to be collinear, so it's called non-collinear.
Oh, cool. So I'm going to put that in a non-collinear place now.
So collinear is points along the same line. Non-collinear would be points not on the same line.
And if we have 3 non-collinear points, that means that there are 0 lines that we can draw through all 3 at the same time.
Beautiful.
Cool. So what this really does is this lets us look at the first postulate that we're going to see this year.
What's a postulate? I forget.
A postulate is something that we cannot prove mathematically, but we have to accept as true.
And
And
like
this is,
Mr. Robert Earth is the best.
yeah, I don't know if I'd say that's true. He's okay. But in terms of the postulate here, that if we have any 2 points, we can draw one line through those 2 points. We saw that on the previous page. We kind of played around and tried to find a way to not do that, but we don't have a mathematical way to show that has to be true. We just accept it because we can see that it is true, and we can't find a way to break it. And that's kind of what a postulate is, something like that we have to accept because we can see that it seems to be true. We can't find any counterexamples, and we can't mathematically prove it.
So now we're going to talk, this one says, when you have 2 or more geometric figures, their intersection is a set of points the figures have in common.
And I'm going to add one that we didn't have earlier, which is going to be a line or a segment.
Look how straight that line was. Good work.
That's because I use the assistive drawing tools.
Oh, it's the best.
I know. So what I was thinking for this is that we can kind of mess around with some of these and move them around and see what happens, and talk about the intersections that these things have. Ooh, this is good because now we get 2 different sets of intersections to talk about.
Oh, you want me to leave it there? I moved.
No, I like that.
I won't click off. I'll leave it there.
Cool. So there are a couple ways that we can deal with this. The first is going to have to make an assumption. And that assumption is that these things are not filled in objects, that the circle that we see on the screen is just the outside part of the circle. It's not any of the inside part. So if we're talking about intersections of the circle and the line, any place that those are crossing is going to be true. Same thing.
Take that triangle. This is very important mathematical stuff. If we take that triangle, let's see, re-rotate it like this. Does it look more like a face? No? I don't know. I was trying.
Cool. It looks like a triangle and a circle. Can we all see that there might be intersections where the triangle and the circle meet up as well?
Yeah, I mean, the circle's still here. It just has to do with a layer issue.
Right.
The circle's still there. But they hit no points.
So the other aspect that we can look at later this year when we talk more about things that are on a plane instead of just talking about intersections as a topic, if we had something where, I don't know, I'm going to try to draw a circle. That's awesome. Cool, I made an oval. And instead we were talking about these things not as line drawings, but as 2-dimensional objects. Suddenly the intersection of like this box and this oval is going to become that whole shaded part that I just shaded in yellow.
You're saying the white rectangle and the gray oval intersect in that lovely yellow shade.
They do.
Yeah.
And most of the time we talk about intersections, that's not what we're going to be referring to. But I think that's a cool thing to talk about now while we have this technology to kind of visualize this.
And if you think of Venn diagrams, the intersection is
Yep.
what you just drew. It's how much they overlap.
So
If you
if we
don't know what a Venn
had
diagram is, think of the three circles that kind of overlap. If you Google it, you'll see it.
3 circles,
2 circles, 3 circles. I often think of three.
generally 2, but we can do a third circle, and then we have lots of different intersections.
There you go.
All right. Ooh, 2 lines in space.
So this is going to be difficult for
Yeah.
a couple of the situations because it's easy if I draw like 2 lines like this. Look, they run into each other. Or if I change my color here and I go 2 lines like this. And those are, I think most of us will be relatively comfortable with the word parallel there. It gets more difficult if I thought of a line on a piece of paper and then a line of your pencil floating in space.
So if I try to draw that, it might look something like this, where this line would be going behind my solid line.
Yes, or if you think of, if you look at my picture now, it's probably small, but you have a line on the piece of paper and then you hold your pencil above it. We could still have parallel lines, but you could rotate it and have not parallel lines. Spoiler,
Cool.
those are called skew lines.
I was also going to add a little bit of notation just to the parallel lines. One of the things that we can do in geometry to show that lines are parallel is mark them with the same kind of like arrow looking tick mark. And that's just a way to identify things as parallel. That's going to be important for us as we go through the year.
And another situation with the 2 lines is we already discussed when I drew the line through the 2 points and then you drew the line through the 2 points and those were the same line. That's what the second question on the page gets to is what if we say those 2 lines have to be distinct? That means they have to be different.
So that would be eliminating the one that looks like this and then has the same thing sitting on top of it and pretending those are 2 different when they're the same.
Yes.
Cool.
And if we, as we continue to nerd out geometrically, if we change that word space, if we change that to a plane, then we don't have to worry about the thing I was talking about earlier, the skew lines idea or anything like that.
So this one would be a case where these things are not coplanar.
Yes, non-coplanar lines.
And that means, so we talked about coplanar points before. Coplanar lines are things that you can draw on the same plane.
By things, you mean lines you can draw on the same plane.
What did I say?
You said things.
Oh, cool. I do mean lines. So if we're dealing with, the only case that we can have things that are not coplanar is when we have these skew lines. And that's another way to think about skew lines as lines that are not coplanar. In fact, that's the simplest definition for them.
So
okay.
We asked those questions because this postulate says if 2 distinct lines, remember that's different lines, intersect, they intersect in exactly 1 point. That's similar to the idea where we had those 3 points, we were trying to draw a line through it.
And this is another postulate. We can kind of see this pretty easily and accept that. We don't have a way to mathematically prove this, but this is a true thing, and it also makes sense.
Well, that should be 2 L's in collinear, so there's a typo there. Sorry about that. So 3 collinear points and 3 non-collinear points. And
we also need the intersection.
I think that they should do this.
Ooh, that's a good one.
And then should we even show them the answer or should we not show them the answer?
Let's go with not show them the answer this time.
That sounds great.
All right, and here we end up with the same type of thing we've been having, but this one's a little bit harder to get our brains around. What the heck's on that sticky note? Is that the link where these came from?
That's the link. It's ridiculous, so I just made it as small as possible because the link goes on forever. It might be because it might have the Google search in it. I didn't pay attention, but I wanted to cite my sources. But anyway, so you have two planes in space. What can happen with them? So I gave some planes here, but it's going to be hard for us to really figure out exactly what's going on. But like, for example, you could have two planes in space, maybe that's helpful, that are parallel to one another. I need to click off of it so that you can actually see that I moved it. So those planes in space are parallel to one another. If you think of holding up two pieces of paper, those could be parallel. We could also have them overlap each other. If I take the plane and I make it overlap over here, what the heck happened with that? Oh, that's fun. It just disappears because those are the same plane. And then if I say rotate it, it doesn't have to be 90 degrees, but I can be like this. Again, issues with the picture, but they intersect. And the key part there is, what does that intersection look like? So if you think of taking two pieces of paper and slamming them into each other, not on top of each other, but into each other, what's that intersection going to be? If you're confused, look at the wall and the ceiling.
Wait, are you saying that the wall is like a plane and the ceiling is like a plane?
Yeah, did I just blow your mind up?
And where they meet, that would be like their intersection?
Yes.
Huh. Well, for me, the intersection looks like a line.
Well, why don't you go to the next page?
What? We have another postulate about planes intersecting?
Right.
And it says that they're a line?
Mm-hmm.
But that's like, I can just look at the wall and the ceiling and see that that seems to be true.
Yep. The spicy part gets to, what happens if I talk about three planes? Shh, don't tell them.
Ooh. Is it the next page?
No.
Oh,
There's nothing on the next page. We are done, sir.
oh, this is just us being fun then?
Yeah. That's just a question I like to ask.
Yeah, that is a fun question. I think that'd be a good one to talk about in class. What do you think?
I agree.